Hi everyone. All right, let's go through this worksheet. So in a certain cross, it shows the following ratios. What are the probable genotypes of the parents? So when I look at this cross, what I see is that I have a black rough, I have a black smooth, I have a white rough, and I have a white smooth. So I have all four possible, and it seems to me like it is in a kind of a 9 to 3 to 3 to 1 ratio. So I'm going to assume that my parents are both heterozygous. I am dealing with two dihybrids. All right, question 2, give the following information to answer the question. So what is the phenotype of big T, little t? So here I'm going to have tall and wrinkled. The genotype for tall, round, so those are both dominant. So then I need to have big T and a big R. It doesn't matter what the other ones are. The gametes of this parent, so when it comes to this pair, the only thing he can give or she can give is a little t, but when it comes to this one, I can get a big R or a little t with a little r. So those are the two possibilities that I can get. It's almost like that foil, right? And so the same thing goes here. I can have big R with big T, big R with little t, little r with big T, and little r with little t. So those are my possibilities. So big R, big T, big R, little t, little r, whoops, big T, and little r, little t. What are the gametes of this one? So the only possible gametes here are going to be little t, little r. That's the only possibility. What is the phenotype of this individual? It's going to be short and wrinkled. Whoops, wrong one. In guinea pigs, the gene for black fur is dominant to the gene for white fur. So I have a pig that is heterozygous for both traits, is crossed with a white smooth pig. What are the genotype and phenotype ratios of the offspring? So again, I have to look at the gametes. This individual can have big B, big R, big B, little r, little b, big R, little b, little r. This individual, the only gametes that it can give is a little b, little r. So I'm going to have a Punnett rectangle. So the little b, little r, one parent is going to go here. And the other parent with its four possibilities is going to go here. And what is the genotype and phenotype ratio? So when it comes to genotype, I have one of each. So I'm going to have to list them all to 1, to 1, and finally to 1. And when I look at the phenotype ratio, this one is going to be black and rough. This one is going to be black, smooth. And then I'm going to have white, rough, and white, smooth. So it's a 1 to 1 to 1 again. So all of them are 1 to 1 to 1 to 1. Okay. And then it says, what are two dihybrids or cross? What is the genotype and phenotype ratios of the offspring? When I have two dihybrids, that means I have this. And anytime we have two dihybrids, we said that we always have a 9 to 3 to 3 to 1 ratio for both the genotype and the phenotype. So for the genotype ratio, I'm going to put 9 are going to be dominant for both, dominant for one, recessive for the other, recessive for one, dominant for the other, and 1 is recessive for both. And when it comes to the phenotype, I'm going to have 9 that have the dominant for both, so brown and rough, and 3 are going to be brown, smooth. So the dominant for one, the recessive for the other. This one is going to be the recessive for one and the dominant for the other. And one is going to have the recessive for both. The ability to taste PTC paper is a dominant trait. So I'm going to put taste, and little t is no taste. And the gene for the ability to roll your tongue is dominant. So I'm going to make my key. Suppose you have a non-rolling woman. So they're doing the rolling part first. So I have a non-rolling woman, heterozygous for tasting, marries a non-tasting man, heterozygous for rolling. So he's non-tasting. Okay. Describe all the genotype and phenotype ratios possible for their children. So again, I'm going to have to figure out what my gametes are. So this parent can give little r big T and little r little t. This parent can give big R big T and little r little t. So now when I'm making my Punnett square, I have two possibilities for each parent. Here goes one. And there goes the other. So big R, big T, little t, big R, little r, two little t's. And so what I have for genotypes, again, I have to write my ratio. See, these are all different. So it's a 1 to 1 to 1 to 1. And my phenotype, I have rolling and taste for 1. I have 1 roll, no taste. I have 1 no roll and taste. And I have 1 no roll and no taste. Okay, so again, a 1 to 1 to 1 to 1. Black coat for Cocker Spaniels is dominant over white. Solid is dominant over spotted. So I have a male that is black with solid pattern, mates with 3 females. So he is black, solid, and he mates with 3 females. Okay, so I have female A is white and solid. So she has like that. I don't know what the other one is, so I'm going to leave it blank. Female B is black and solid, and female C is white and spotted. All right, so now let's look at their pups. So female A's white solid produces 2 pups, 1 black solid, which doesn't tell me much, and 2 white solid. So white and solid. So now when I look at this pup, this little B came from mom. This other little b had to come from dad. So I do know that dad is a carrier of the white allele. So he has the white allele. Okay, the rest doesn't tell me anything. So let's look then at female B. So female B, which is black solid, produces 1 pup that is white spotted. Oops. So white spotted. So again, when I look at this, 1 little b came from mom, so she has 1. The other one came from dad. 1 little s came from dad. 1 little s came from mom. So I know that both mom and dad are carriers of that little s allele. Okay. Now when it comes to the third female, she is white spotted and produces 4 pups, a black solid, a black spotted, and 1 white spotted. Okay, so in this case we already have no dad, so it wants to know showing all the genotypes for each of the crosses. Okay, so the only thing I have left with is this mom. So given that both the pups have, so this mom, so given that both the pups are solid, I'm going to assume that she is homozygous for that. And then that gives me all of the genotypes for all of the kids. Now this one, if mom has the big B, the little b, that's the only thing she can give the offspring. And so I'm going to put that. And the other one, I don't know, so I'm just gonna leave it blank. And then here for this one as well, since mom has this and this, then what I do know is they got that from mom. And so I can fill those out for that. So the only one that I can't be sure about is these two. Okay, if you wanted to, you could make them homozygous for it or heterozygous for it, but we're just gonna leave it blank for that. Okay, and that's it for the